exterior angles, and corresponding interior angles. You guys seem to have a very good grasp on that right now. So today, we're going to look at that same kind of idea, but this time our transversals are going to cut through which types of lines here according to our title? Parallel lines. We're only looking at the case today where two lines that we have are going to be parallel, somewhat like this. So you've got two lines that are parallel right here. And again, to indicate that they're parallel, what do I need to put in those?
The line through it.
Well, not the line yet. We'll put the transversal through, but don't I have to put these little symbols in here, these little arrow symbols like this to indicate that those lines are what type of lines?
Parallel.
Parallel, you bet. And now we're also going to talk about parallel lines. And the only types of lines we're going to see today where lines A and B are cut by transversals are parallel lines. We're going to explore what's going on with this right here today. Okay? So we're talking about two parallel lines. In this case, A is going to be parallel to B. And it's going to be cut by this transversal T right up there. All right? So in the last section, we didn't always have parallel lines A and B. That didn't always happen. So today we're going to look at what happens with all the angles that are formed when two parallel lines are cut by a transversal. Question today is, when two parallel lines are cut by a transversal, which pairs of angles are congruent? So in order to look at solving this today, or answering that question, we need to be able to use properties of parallel lines. We need to prove some theorems about parallel lines, which I'll show you in a second, and then look at some real world problems. Okay? So, here we go. First vocab word that we need to make sure we understand, corresponding angles. Okay? Corresponding angles. I think we remember this. I'm going to put a diagram up here. If I cut this by a transversal, and then put some angle measures in here. Somebody give me a pair of corresponding angles right here. And that's two lines that are cut by a transversal. What's one pair of corresponding lines? Or, I'm sorry, corresponding angles. 1 and, ooh, careful.
1 and 7.
Slide this cluster down and see where it would fall. One would
and
fall
5.
on,
1 and 5.
yeah, there you go. 1 and 5 would correspond to each other. So we'll want to make sure that we remember what corresponding angles. Heck, let's just make sure we're good with this. It says angles in the same relative position when two lines are cut by a transversal. So 1 and 5 is a pair. What's another pair again, kids? 2 and 6.
8 and 4.
8 and 4.
3 and 7.
And 3 and 7. Okay, so I think we've got that. So we need to remember corresponding angles. Okay. Again, parallel lines. We understand parallel lines are two lines in the same place that will not cross. Again, I'll just remind you that if you have parallel lines in any diagram, you're always looking for that symbol within the two lines that say, oh, these are parallel. Come on, come on. If I called this line A and this line B, I would write down in this case then, by those two arrows through those lines, it's simply saying that A is parallel to B right there. Okay? Supplementary angles, I shouldn't have to review this with you. You should know this. Supplementary angles are two angles that add up to 180 degrees. I have a 120 degree angle. What's its supplement? 60. Okay? And then vertical angles are two angles that are opposite of each other that are formed by intersecting lines. So I would just do this. Here's two intersecting lines right here again, kids. Make sure we understand vertical angles. Which pair of angles are opposite each other or vertical in my diagram? Which one? Which angles are vertical right here? Thought I heard somebody say it. I just didn't hear you. Say it again. 1 and 3. What's another pair of vertical angles? 2 and 4. Okay? Agree? All right. Guys, down here we're going to talk about some theorems right here. And these theorems really are going to be rules about parallel lines that are cut by transversals. All right? So let me draw this up here quickly. Let's start with this. You're going to do the same thing. I want you to draw this diagram for all of these. And honestly, I'm going to use the same diagram for all these theorems. So we'll put the diagram right here. So let me draw this quickly. You draw the same thing. First of all, we're cutting what types of lines with a transversal now? What types of lines are we really worried about today? Parallel lines, all right? Take these parallel lines and cut it by a transversal. Okay, what I want you guys to do is this. I want you to, I need to think here quickly. Yep, let me draw the diagram this way. Let me blow this up. We're going to use this diagram for all these theorems right here. Okay, first of all, label your angles as I am here. 1, 2, 3, 4, 5, 6, 7, and 8 again. Okay? Label them as I have right there. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And again, the big idea here today is this. These lines are parallel now. These lines are parallel. Now, these theorems that I'm about to throw at you are going to be kind of difficult. They're going to sound like, ooh, gosh, they're a lot of words, a lot of, well, I'm not sure what this means, but I'm going to tell you right now, what's in these theorems are all things that we've discussed so far, okay? Might help if I open it up right away. Works better when the top's open. Nope. All right. Corresponding angles theorem. First of all, we know what corresponding angles are. Listen carefully right here. These are always going to be prefaced by the following. It says if what kind of lines right here in this first theorem, kids? If two parallel lines are cut by a what? If two parallel lines are cut by a, that's what we have in this diagram right here. I'm going to use this idea that this is line A, and this is line B, and then we're cutting this by our transversal T. It says then the pairs of corresponding angles are congruent. So what this is saying is this. First of all, angle 1 must be corresponding to what? What's angle 1 correspond to? 5. Okay. What this is saying is this. Under the condition that lines A and B are parallel, if you cut by a transversal, it says corresponding angles are equal. In other words, if angle 1 was 120 degrees, what would that make this down here? 120. Now, this is only true if you have what types of lines, kids? Parallel lines. Then the pair of corresponding angles are congruent. So in the example of the diagram, angle 2 has to be congruent to angle what? What must angle 3 be the same as? Angle 7. They correspond to each other. Okay? So that's what's going on there. This is also going to go on to say the same stuff about all the other angles that we discussed in the last section. Same is true for alternate interior angles. It says, if two parallel lines again are cut by a transversal, then alternate interior angles are congruent. So in the example that I have right here, if I'm talking alternate interior angles, it says, well, take a look at this. 3 would be alternate interior to what angle, kids? 3 would be alternate interior to what? 5. Okay, 5 in this case. And then 4 would be alternate interior to 6. If I told you angle 4 was 60 degrees, what would that make angle 6? Alternate interior angles are going to be equal. Now, I'm not going to go through the rest of this. You need to also understand that if you have two parallel lines cut by a transversal, then what's going to be true about alternate exterior angles, kids? They're going to be congruent. Okay? So these are 3 theorems right here where we say, well, if I have parallel lines cut by a transversal, these 3 theorems are going to produce such a situation where corresponding alternate interior, and alternate exterior angles are all, and I'm going to put this symbol right out here by these three. They're all congruent. Okay? Angles that correspond, angles that are alternate interior, angles that are alternate exterior, formed by a transversal cutting through parallel lines are all going to be congruent. Okay? Now, there's one more theorem we'll look at here quickly on the second page. Before I move on to the second page, do you guys have that stuff? All right, holding on. I'm holding on. Holding on. Anyone else need more time getting that?
You go this way.
Are we good?
No, 'cause I mixed up that.
Are we good? Where'd you mess up, Jay? Done?
I thought that said 113.
That's a symbol of congruent. That pen, where the pen mark is, throw you off. All right, let's move on to the next one. All right. So right here at the very top, last theorem. This one here is a little bit more difficult. I'm going to draw the diagram again. I think you should do the same. Draw the diagram right up here again. So two parallel lines, which I'll indicate are parallel by these arrows, cut by a transversal. Say, oh, I don't know. This is transversal T. Whoops. This is my transversal T. This is my line A. This is my line B. Let's suppose that this is angle 3. This is 4. And this is 5. And this is 6. Okay? All right. Consecutive interior angles theorem. This is the one that maybe differs a little bit than the other three. Again, the other three said if you have alternate interior, alternate exterior, or corresponding angles where a transversal cuts through parallel lines, you will have congruent angles. Now the difference here in this one is this. When we start talking about consecutive interior angles, this is a little bit different. Again, it's prefaced by if two parallel lines are cut by a transversal, then the pair of consecutive interior angles are, this time, what's the word that I'm highlighting?
Supplementary.
They're supplementary, okay? First of all, what are my consecutive interior angles in this? What's one pair of consecutive interior angles?
3 and 5.
3 and 5. They're not saying anymore that 3 and 5 right here are equal. They're saying they're supplementary. And take a look at this, guys. Is angle 3 obtuse or acute? Obtuse. Is angle 5 obtuse or acute? So there's no way that consecutive interior angles in this situation are going to be equal. So right here I could say angle 3 plus angle 5 here has to add up to how many degrees if they're supplementary, kids? Okay, so this is simply saying angle 3 plus angle 5 then must equal, whoops, I forgot the 5. Plus angle 5 must equal 180 degrees. Therefore, what's true about the sum of angle 4 and angle 6 if you have parallel lines cut by a... Okay, again, those are consecutive interior angles. They must be supplementary or sum to 180 degrees. All right, so those are all those theorems we're going to talk about today, where we have parallel lines cut by a transversal, and we're going to talk about angle measures as they relate to parallel lines cut by a transversal. So let's take a look at example 1, identifying angles. Let's do this right now. First of all, I'm going to label some lines. I like to label my lines. Call this line A, this line B, and we're going to call this T that cuts through those two parallel lines. All right? And then we have to identify some angles. So here's what I want you to write down here. Give yourself some room. All right, let's take those theorems. Corresponding angles theorem, alternate interior angles theorem, alternate exterior angles theorem, corresponding interior angles theorem, and put them to work here. Okay, guys, line A and B are what type of lines based on these red marks? A and B must be parallel. The marks up here tell us that, and then it's cut by a transversal. Guys, they're saying right here, this is really the measure of angle 1 right here. Angle 1, Right there is 120 degrees. Okay? Anybody know what angle 2 is?
60.
Why is it 60?
Because it would go from 80.
They would add to 180. They're supplementary, right? They're a linear pair. Stuff that we've had here. So angle 2 has to be 60 degrees. Good. How about angle 3? 60 degrees, because 120 and 60 right here. Guys, aren't angle 2 and 3 vertical angles? Have to be the same. So angle 3 would have to be what?
60.
Okay, how about angle 4? Holy cow, we got a race now. How much, Jaden?
120.
Why 120?
Because it is vertical to 120.
Okay, it's very good. Vertical of 120. Here's the big idea today, and we'll see how this transfers over. Anybody have a guess on what angle 5 might be?
120.
Why are you saying 120, Kaylin? Or Jaden?
Because the lines are parallel.
The lines are parallel.
Have to be parallel.
So your reference.
They're corresponding angles.
They're corresponding angles, and we just learned that if you have parallel lines cut by a transversal, corresponding angles are they're corresponding, but their measures are going to be the same, congruent, you bet. So what she's saying right here is, well, this angle 1 corresponds to angle 5. So 1 and 5 by parallel lines cut by a transversal have to be the same. So what's angle 5 going to be again, guys? Well, 120 degrees. Quickly on angle 6, what is that going to be? 60 degrees. How about angle 7? 60 degrees.
Next is 120.
And angle 8 is 120. Very good, guys. Okay? So here's the deal. If I have parallel lines, this whole cluster of angles, 1, 2, 3, and 4, has to match this cluster of angle measure-wise, because we're talking about parallel lines cut by a transversal. You know one cluster, the other cluster is exactly the same. Okay? All right, kids, let's talk. This is where things get a little tricky. Okay? This is where things get a little tricky. It says find the value of what, kids? X. All right. In this situation, I'm going to blow this up a little bit. Find the value of X in this diagram. First of all, you have two lines, A and B, that are parallel, cut by this transversal T right here again. Okay? Yeah.
So you would put 115 plus X plus 5 is equal to 180.
Why are you adding them up, kiddo?
Because they add up to 180.
Yep. Yeah, and exactly. They put this angle 4 here for a reason. If 115 is up here, what's this make this angle degree-wise down here?
115.
So this is 115 degrees in here. So what I have here, to find this x, to relate it to some other angle in here, I have the 115 and the x plus 5. Aren't those consecutive interior angles? And by consecutive interior angles theorem, we would have to say that those two angles are supplementing. Or in other words, again, Jaden, you want to do what here? Okay, so we're going to add this up. We have that 115 degree angle plus x plus 5, and that's equal to 180. Now guys, here's how I kind of think about this. And I'm going to kind of back up on some of these numbers here. I always look at these, and this is how I think, and maybe this will help you think. Look at the 115 in blue. Is that angle acute or obtuse? Look at the x plus 5, what we're trying to solve for x. Is that angle acute or obtuse? So you have one that's obtuse and one that's acute. Is that correct? So is there any way that we can set those equal to each other? No. If one's obtuse and one's acute, they're not going to have the same measure. So therefore, that would be the situation. We have to take the two, add them together, and then set it equal to what value? 180, right? All right, so we get here. What's 115 and 5 add up to, kids? What's 115 and 5 add up to combine two here?
65.
Okay. Won't this become x plus what, kids, on the left?
X plus 120.
Very good. Solve for x. What do you have?
60.
Now, guys, I realize it says just find the value of x in this, but some of the problems you're going to go into further are going to say, what's the measure of that angle? Well, if I wanted to find the measure of this angle right up here, we'd have to substitute right back in here. That would mean that that angle is 65 degrees. Okay? All right, very good. Let's see how well we're doing with this. What I want you guys to do is this. On the next page, example 3, top of the next page. You guys try that on your own. See if you can come up with a value of x here, okay? When you've got an answer, check with the neighbor around you. See if you agree or disagree.
Divide sign.
You show of hands when you're done too. So example 3, give that a shot on your own. What x equal again, kids? On example 2? Thank you, Carly. Okay, kids, anybody have a value for x here? 45?
No, just 5.
65?
X equals 5.
X equals 5?
Caitlin did it wrong. Yes, huh?
All right, let me ask this question. Let me ask this question.
Do it right. Yes, sucker.
Then what's 127 divided by 7?
I'll do it in a second.
Couple different ways to do this.
Caitlin did it wrong.
Let me ask this question. They give you angle 1 right up here for a reason. Okay, could you figure out the measure of angle 1 first of all? How much? 44 degrees, right?
I got that. I just took my answer.
How does angle 1 and this angle down here where we're trying to find a value for x, how are they compared to each other then?
You have to set them equal. Or
Set them equal to each other because they are alternate exterior angles, okay? One way of doing it is just saying, well, I can go 44 equals 7x plus 9. That would be one way to do this. Or another way, say, well, this angle up here was 136. Was that acute or obtuse up here, kids? Yeah, 136 would be, and then this would be an acute one. So if you ever have an obtuse angle and an acute angle within parallel lines, another way you could have set it up is go 136 plus,
7x plus
and set it equal to what, Lane? What could I have set that equal to? 180, because this angle right here would be the same as this one right here, wouldn't it? And those two would add up to 180. Let me ask this question. How many set their equation up the first way? How many went the second way? Either way, you're going to end up with the same answer. What's 44 minus 9, kids? So that makes your x value of 5 right here.
Was right.
Okay?
I was right too.
I want to show you this right here. What's 136 and 9 add up to? Well, it's 145. Watch what happens here, kids. Just watch what happens here. When I subtract 145 from 180, when I subtract, I get 7x equals 35. Wasn't that a point in the equation over here on the left? Was, wasn't it? Same thing. X value is going to be 5. Right?
Carson, do you have a paper clip? No.
All right. Next one. I want to put a star by example 4.
Back now.
Put an example
It's a
4.
Well, it wasn't very
Yeah.
nice of her.
Here we go. This is an important one right here. You're going to want to make sure you understand what's going on here. Okay? Guys, it says prove that if two lines are cut by a transversal, then the pairs of, I'm going to underline this, we need to show that alternate interior angles are what? Have to show that what? Help me, guys. What's it say? What are we trying to show? Hello? Stay with me, please. Get off your phones and stay with me. Alternate interior angles are congruent. Okay? Alright, it says draw a diagram, label a pair of alternate interior angles such as angle 1, angle 2, and angle 3. Okay? It says you're looking for an angle that is related to both 1 and 2. Notice that one angle is a vertical angle with angle 2, and one is a corresponding angle there. Alright? Here's how this is going to work. We have the diagram labeled. Okay? With 1, 2, and 3. Alright? First of all, anytime we try to do a proof in the last section, we always have to start out with something that is given. Okay? In this diagram right here, kids, we know that line P is parallel to line Q by these two marks, don't we? Don't we know what line P and line Q are parallel? Okay, all these lines have been parallel. So reason number one, it says line P is parallel to line Q. We know that in that diagram. Okay? Now, in step 2, we're trying to show that alternate interior angles are congruent. 1 and 2, in other words. Okay? So here's how I'm going to do this. I'm going to say, you know what? I could say this. Angle 1 has to be congruent to angle 3. Angle 1 and 3 are going to be congruent because these are what types of angles?
Parallel.
Not parallel. What types of angles?
Corresponding.
Corresponding. Okay? Corresponding. Okay? I'm going to abbreviate my reason for this. What's that mean?
Cat. Corresponding ulterior.
Angles.
Corresponding.
Corresponding angles theorem. There you go. Corresponding angles theorem. Okay? Now, in the next one, I can say this. Watch what I put. Angle 2 is congruent to angle 3. Why are angle 2 and angle 3 congruent in that diagram? Why can I say 2 and 3 are congruent? Well, look at 2 and 3. What makes them? They're vertical. Okay? I'm going to put this down, which probably stands for what?
Vertical.
Vertical angles theorem. Okay? Now, take a look at this right here, kids. We're trying to show that 1 and 2 are equal. Here I have 1 equal to 3. Here I have 2 equal to 3. So what's that mean about 1 and 2?
They equal 2.
Okay, so this means that number 4, to show that alternate interior angles are equal, I can say angle 1, which is alternate interior to angle 2, they are equal by, I'm going to put this down here. See if you can figure this out. 1 was equal to 3, and 2 was also equal to 3, therefore 1 and 2 must be equal. It's stuff that we've talked about in the past. Which property is that? Starts with a T. Transitive property of congruence. Okay? So right there, you've shown that 1 and 2 are the same, therefore you've proved that angles 1 and 2, alternate interior, are equal. All right? So take a second and have that down. Anybody need more time? Anybody need more time?
No.
Okay, last one here. Real world example. It says when sunlight enters a drop of rain right here, different colors of light leave the drop at different angles. The process that makes a rainbow. It says for a violet color, angle 2 must be how many degrees here, guys?
40.
Okay. Now right here, kids, angle 2 is how many degrees again?
40.
This is 40 degrees. Okay? Question says, what's the measure of angle 1 and how do you know? Well, here's the sun's rays and your angle looking down there, guys. What's true about these two yellow lines? They're parallel. So if angle 2 is 40, what do you think angle 1 has to be?
40.
How do you know?
Because they are parallel.
They're parallel, but how are 1 and 2 related?
They're parallel.
Well, wait a minute. The lines are parallel, but how are angle 1?
Alternate interior.
Alternate interior angles. Yep. Okay. So I'm going to write this down. By alternate interior angle theorem, angle 1 must be equal to angle 2. Since angle 2 is how many degrees, kids?
40.
That means the measure of angle 1 must be 40 degrees. Okay? Guys, I think that this section is pretty simple. It's a lot of, if I know one angle, I should know the rest when transversals cut through parallel lines. Now keep in mind, these angles are only going to match up when you have what types of lines cut by a transversal again?
Parallel.
We're looking today specifically at what happens when parallel lines are cut by transversals. So make sure that you know what you're dealing with parallel lines before you even move on. Okay? What questions have you guys got? Okay, I'm going to stop recording this.
What?
Yep. You've been recorded today.